Have you ever seen a message just appear out of thin air? It sounds like magic, right? Well, today we're heading to a school science fair to solve a mystery that looks just like a magic trick, but is actually some really clever chemistry that you encounter in your own life all the time.
So, our story kicks off with two siblings, Ashwin and Kirti. They walk into the entrance of the fair, and they're handed what looks like a totally blank sheet of paper. A little strange, don't you think? You can just picture them looking at each other, wondering, what's the deal with this?
But then, just a few feet inside, a volunteer comes over with a spray bottle. They take the blank papers and give them a quick spritz with this clear liquid. And just like that, like invisible ink, a message starts to appear. Welcome to the wonderful world of science.
Well, you can bet Ashwin and Kirti were immediately hooked. I mean, come on, who wouldn't be? To them, this wasn't just some cool trick. It was a puzzle, and they were absolutely determined to figure out the real science behind it. And that really brings us to the big question, doesn't it? How is that even possible? Is it some kind of magic, or is it chemistry? Well, let's join them on their investigation and find out. Now, the first step in solving any good mystery is to look for clues. And in chemistry, one of the best ways to understand what something is to see how it reacts with something else. Our very first clue comes from a simple experiment called the litmus test. To crack this case, we need a special kind of tool, a chemical detective, you could say, called an indicator. Think of it as a spy. It's a substance that changes color to reveal the secret identity of other chemicals, telling us if they're an acid or a base. And probably the most famous one is litmus.
So Ashwin and Kirti decided to run a little experiment of their own. They just grabbed some everyday stuff from around the house, put a drop on little strips of red and blue litmus paper, and then just watched to see what would happen. And check out what they found. The lemon juice made the blue litmus paper turn red almost instantly. The soap solution did the complete opposite. It made the red litmus paper turn blue. And plain old tap water, it didn't do a thing to either of them. These very different reactions are our first major clues.
That first result gives us our first category of substance, acids. Things like lemon juice or even vinegar that turn blue litmus red are called acidic, and you've probably noticed they often have that characteristically sharp, sour taste.
Now, on the other side of things, we have bases. This is our second category. For stuff like that soap solution that turns red litmus blue. Basic substances often feel kind of slippery, which is exactly why things like soaps and cleaners are usually bases. So in our chemical world, we have these two key teams, acids and bases. But here's where things get really cool. These chemical detectives, these indicators, they aren't just things you make in a lab. Nature has its own, and you can find them in some pretty surprising places. I mean, take red roses, for example. I know it sounds a little unlikely, but if you soak their petals in hot water, you can actually create your own natural indicator liquid. And this homemade indicator works beautifully. When you add an acid to the rose water, it turns a reddish color. But when you add a base, it turns greenish. It's a simple, homemade way to tell the difference. Oh, this is such a great real-world example. Turmeric, the spice that makes curry yellow, it's also a natural indicator. Think about it. If you get a curry stain on a white shirt, it's yellow. But when you put soap on it to wash it out, the stain turns red. That color change is just chemistry in action, right there on your clothes. Okay, so we're getting the hang of how to spot acids and bases using indicators. Now, let's put them head-to-head to really understand the two culprits in our mystery. The most important thing to remember here is that they are basically chemical opposites. One is sour, the other is bitter. One feels normal, the other feels soapy. One turns blue litmus red, the other turns red litmus blue. This whole opposites relationship is the key to everything. Now it's time for the final piece of the puzzle. We know what acids and bases are, but what happens when you actually mix these opposites together? This is where we finally find the solution to the science fair mystery. The process is called neutralization, and a great way to think of it is like a chemical tug-of-war. When you mix an acid and a base in just the right amounts, neither side really wins. They just cancel each other out, leaving behind a new substance that's neither acidic nor basic. It becomes perfectly neutral. And the chemistry is actually pretty simple. An acid plus a base reacts to create two neutral things, salt and water. You also notice a little bit of heat gets released, and that's just a sign that the chemical reaction happened and the original properties have been neutralized. So let's bring it all back. We know that indicators change color when they come into contact with a base.
So, how does that explain the message that just appeared out of nowhere? And there it is. The secret message was written with an invisible basic solution, something simple like baking soda and water. The spray bottle was just filled with a natural indicator, maybe from roses or turmeric, so when that indicator was sprayed on the paper, it reacted with the invisible base, changed color, and revealed the message. No magic at all, just some brilliant chemistry. And you know this isn't just a cool trick for science fair. This chemistry of acids, bases, and neutralization is happening all around us, every single day, in some really important ways. Here's a perfect example. Ever been bitten by an ant? That stinging pain is caused by something called formic acid that the ant injects. But if you apply a little bit of moist baking soda, which is a base, it neutralizes the acid right on your skin and helps make the stinging stop. That's neutralization saving you from an itch. So whether it's soothing the sting of an ant bite or revealing a secret message at a science fair, the hidden chemistry of acids and bases is literally all around us. It just proves that the world is kind of like a giant laboratory, just full of mysteries waiting to be solved. The real question is, now that you know what to look for, what will you discover next?